In this video we're going to take a look at conic sections and exam style questions when transformations are applied. The main type of conic sections that we need to know about are parabolas, ellipses and hyperbolas. And this first question that we're going to look at is a past paper question on hyperbola. Okay, so it says the diagram shows a hyperbola, x squared over 4 minus y squared equals 1 and its asymptotes. And the first part of the question says write down the equation of the two asymptotes. And part B says the points on the hyperbola A and B are when x equals 4, and we want to find in third form the y coordinates of A and B. Once we've done that, then we'll think about some transformations that are applied. Okay, so for the first part, if you want to find the equation of the asymptotes, look at the equation of the hyperbola. And you always want to compare it with the general form. Very important, first of all, that we need it to be equal to 1 on the right hand side. And we've already got it equal to 1. So now we can compare it with this general form. And obviously, clearly, I mean, you might not need to write this, you might just be able to see it, but if it's over 4, we can think about A as 2, because it'd be over 2 squared. And if we just write y squared, obviously that's the same as dividing that by 1 squared. And the formula booklet helps us for this. So we can, if you can't remember this, you can actually look into the formula booklet for what the asymptotes are. And this is what it looks like in the formula booklet. It says x over A is equal to plus or minus y over B. I prefer to think about it like this. If you just rearrange this, y would equal plus or minus b over ax. If you just multiply both sides by b and the plus and the minus. Because obviously when we write an asymptote, it's going to be a y equals a constant times by x, because the asymptotes always pass through the origin. Obviously for the original hyperbola, if a transformation is applied, which we'll see later, the asymptotes will move as well as the hyperbola moving. But the original asymptotes pass through the origin, so all we care about is this gradient. So we could say therefore the asymptote, so y is equal to plus or minus b over a, so in this case it would be 1 over 2 x. If you were asked to sketch this, I know this one, the sketch has been given to us already, but if you are asked to sketch this, you should bear in mind this gradient, because obviously that gradient for the asymptote is a half. Just as a quick side note, if you were drawing, say for example, x squared minus y squared over 4 equals 1, so if it was the other way around, the asymptotes would be y equals plus or minus 2x. And if you were drawing that hyperbola, you would need to make sure the gradient of that was steeper than the gradient of the other one. If they give you an axis, obviously try and draw it to scale. But the main thing to look for is that if the gradient is steeper than 1, you want the angle to be more than 45 degrees, and if the gradient's less than 1, you'd obviously want the angle to be less than 45 degrees. Okay. So part B isn't really a conic sections question, it's just more of a general understanding of how equations work and graphs. It says the points on the hyperbola for which x equals 4 are A and B. So essentially, if they give you the x coordinate and you want to find the y coordinate, all we have to do is say, well, x equals 4. What does y equal? Use the equation. We'd get 4 squared over 4 minus y squared equals 1. Rearranging this, that would be 16 divided by 4, also known as 4 minus 1. Would equal y squared. You can clearly see here, just look at the diagram, you can see there's going to be 2 solutions, and obviously these hyperbolas have a lot of symmetry involved as well, so you should already realise that whatever the y coordinate for A is, the y coordinate for B would be the negative version of that, just because it's symmetrical about the x-axis, isn't it? So plus or minus, don't forget to square root with the plus and the minus. So we could say therefore A would be 4 root 3 and B would be 4. minus root 3. So the next part of the question is where we think about the translation. And it says the hyperbola and its asymptotes are translated by 2 units in the positive y direction. Write down the y coordinate of the image of the points A and B. And then we also want to think about algebraically what happens to the equations of the hyperbola and the asymptotes after the translation. So when we see a question like this, first of all, we could think about, well, Jim, looking at the diagram, what would it do to the graph? And if you translate by 2 units in the positive y direction, clearly you can see that we mean that we're moving the graph up by 2. Okay. We also maybe should interpret this in terms of a vector of translation. So the vector of translation we'd say would be 0, 2. Now we have to be a little bit careful here. Well, actually we have to be very careful, because when you do this in A-level maths, you might think about this slightly differently. Let me just do a little side question. So say if we had y equals x squared, and I say translate that by the vector 0, 2, I'm assuming that most of you would write x squared plus 2. Like the way you would interpret this from an A-level maths perspective is you'd think, well, if it's translated by 2, we just add 2 to the equation. And that does work for A-level maths, and that's correct. Because if you think about the x squared graph, and then if we translate it up by 2, clearly the equation is y equals x squared plus 2. Okay? But we can't use that technique of just adding 2 to the equation, and the reason why is because if you look at the actual equation itself, it's not written as y equals a function of x. There's a y within the equation. And if you just add 2 to this, it will not work at all for this further math style question. Okay? We need to think about it differently. And actually I think it's probably easier in further maths because the rule for x and y are the same. If you think about this, we want to, instead of thinking about adding 2, think about it as replacing the y value with y minus 2. Just like if you were doing it for x, I'll do one of those in a second, you'd realise that you'd be replacing x with the negative version of this. And look what I mean, like, you've got away with just adding 2 on here, but really what you should realise is, if the translation's 0, 2, we replaced y with y minus 2. Oh, sorry. And then, if you rearrange that, you would end up with y equals x squared plus 2. So it looks like you've just added 2 to the equation, but really what you've done, or what we should be thinking about, is replacing y with y minus 2. Just like, let's do another one. If we were going from y equals x squared and we translated with the vector 3 minus 1, then what we should realise is we're replacing y with y plus 1, and we're replacing x with x minus 3 squared. So it'd end up looking like y equals x minus 3 squared minus 1. And in A-level maths, you'd just probably skip straight to this answer, because you'd see the 3, you'd replace x with x minus 3, you'd see the minus 1, and you'd just take away 1. But we need to think about this intermediate step. In reality, what you're doing is, if you're replacing x, you should also be replacing y. Okay? So with that in mind, let's see. So first part's dead straightforward. It's just asking what the coordinates do, and obviously you can just see, if you move it up by 2, the image of a, which we can write as a with a dash, the x coordinate would still be 4, but if you add 2 on, it would be root 3 plus 2, and the image of b, the x coordinate would still be 4, but it would be minus root 3, and then you add 2 on. And the coordinates are clearly just increased by 2, but when we think about the equations, we have to think about what I was talking about earlier, where we replace something. Okay, so x squared over 4 minus, a bracket is very important here. If the translation is 0, 2, replace y with y minus 2 and then square it. Okay, it's not a show question, we don't need to rearrange it into any certain form, like we could just leave it like this. You might be tempted to expand this bracket out, but I would probably just leave it like that. That would give you the mark for what the hyperbola looks like. Okay, we also need to realise that if the hyperbola is translated, the asymptotes would also be translated. Okay, so if you want to think about the asymptotes after the translation, it would be, these are asymptotes y equals plus or minus a half x. And because this one is a y equals, you can just add 2 to that side if you want to. So you could just write plus 2, and that would give you the right answer. But just to get us used to thinking about what we should really be thinking about on this topic, if the translation 0, 2, we're replacing y with y minus 2. So we could then say, therefore, y equals plus or minus a half x plus 2 would be our asymptotes. Example 2, we don't need to worry about the diagram. It just tells us we've got a parabola, which is x equals 2y squared, and it's translated by the vector AB to become this equation, x equals 2y squared plus 8y plus 11, and all we're asked to do is to find a and b. Just for reference, you guys will already be used to parabolas, which are that way, which is a y equals x squared. But if it's the other way around, it looks like this. So that would be an x equals y squared. Geometrically, we'll see this in some other questions. If you swap x and y around, notice from that equation to that equation, so instead of y equals x squared, we've got x equals y squared. When we swap x and y, what we've done there, it's actually a reflection in the line y equals x. So if you think about the line y equals x, and just visualize if you reflect this curve in this line, it would go to this curve here, it would be like this. I'm not giving myself enough space to draw it, but that part would get reflected to there, this part would get reflected to here. Maybe a little bit more difficult to visualize this, but you can see that bit, if you reflect it, would come down here. When you are drawing parabolas, just like, you know, when you draw an x squared, you don't draw it going vertical like this. Like, you should always, whenever you draw an x squared graph, it should be a smooth curve. Same for this way, it should be smooth that way. You never want to draw it going horizontal like this, that's not correct. So just make sure it's like, you can clearly see it keeps increasing like this. Okay, anyway, all we have to do is focus on the algebra for this. So, first thing I would do is I think, well, if the original parabola is translated by this vector, let's see what it would look like. Okay, so x is being translated by a, so if we replace x with x minus a, use a bracket. I know you don't need the bracket here, but it's just good practice to get used to using brackets. It's very important. The translation's b, so we'd be replacing y with y minus b. Now we know what the answer is. The answer looks like this. So what I'm aiming to do is say, well, I know that if I translate the original parabola, algebraically it looks like this. And I know the answer ends up looking like this. Can I compare these two things together? So if I can compare my translated parabola with the answer, I'll be able to figure out what a and b are. And all we have to do is like a little bit of rearranging, and we can compare these two things together. You could complete the square on this, or you could expand this. And I think maybe if we expand this, we can just compare these two. But maybe as a bonus question, try and complete the square on this, because it's good practice. You'd have to take the 2 out first. And then once you complete the square on this, you can compare it with this translated form. But if we expand it, we'd get y squared minus 2by plus b squared. So x would equal 2y squared minus 4by plus 2b squared plus a. So that's what our translated parabola looks like when we translate it by this general vector. And we know our answer is x equals 2y squared plus 8y plus 11. So the technique we can employ now is, it's called equating coefficients, but you should just be able to logically compare these, like this is the same, this is the same. So that must be the same. And that must be the same, mustn't it? So we can say therefore minus 4b must equal 8, b must equal minus 2, and 2b squared plus a would equal 11. We already know b is equal to minus 2. So that would give us 8. So a would equal 3 and b would equal 2. Okay, thank you.